Hello everyone, my name is Kirk Key and this is a video presentation of a paper co-authored with my advisor, Dr. Larry Browning at the University of Texas at Austin. The title of our presentation is the Dialectical Tensions in the Funding Infrastructure of Cyber Infrastructure. This video is only a brief overview of the paper, which can be found on the ICA 2010 paper management website. If you're interested in the details, please feel free to download the full paper. And if you do, and you have questions, thoughts, or comments to share, please feel free to contact either one of us, and we will be very delighted to hear from you. Okay, let me get to the meat of this paper. I would like to begin by first unpacking the key terms in our title. What is cyber infrastructure? In our paper, we cited a few sources to define this term that became official in 2003 when Atkins et al. Submitted the Blue Ribbon Advisory Report on Cyber Infrastructure to the U.S. National Science Foundation. Essentially, we frame cyber infrastructure as a social-technical system. The technical components include the hardware, software, algorithms, computing systems, data storage systems, advanced instruments, data repositories, and visualization environments that enable large-scale scientific research funded by the National Science Foundation and other federal agencies. The social elements include the communication, institutions, personnel, and people involved in the development and implementation of this national infrastructure for open science and distributed scientific research. When the social and the technical layers collapse, we see Rebus and Finhol's 2009 observation that cyber infrastructure without people is not cyber infrastructure. Perhaps one of the best known arguments along this line was advanced by Charlotte Lee and colleagues in 2006 when they proposed the concept of human infrastructure of cyber infrastructure as the arrangement of organizations and actors that must be brought into alignment in order for work to be accomplished in the context of distributed scientific research and collaboration. The main assumption is that cyber infrastructure is a socio-technical system of people and technology that is effective only when it interacts. Now, I would like to briefly talk about our theoretical lens of dialectics. So what is a dialectical tension? There has been quite a bit written on dialectical tension in the interpersonal communication literature, especially work by Don Braithwaite and Betsy Bug. In this paper, we drew from organizational communication, primarily work by Linda Putnam and Gail Fairhurst. Fairhurst 2001 defines dialectics as the co-presence of two relational forces that are interdependent but mutually negating. Putnam 2004 further explains that the study of dialectical tensions centers on contradictions or the ways that oppositional forces create situations that are both and or either or. Also, dialectical tensions exist in interdependence, so the tension actually unifies the two seemingly opposing forces involved. To offer two physical metaphors, the arc of a bridge, whose opposing force gives it strength, and the hollow body of an acoustic guitar, whose frame holds it apart, are both examples of parts that give strength to the structure. So next, let's discuss the findings. So based on 60 plus interviews across 17 U.S. states with a wide range of stakeholders, the interviews were conducted mainly in 2008. We identified 6 dialectical tensions across 3 scales of institutions, individuals, and ideologies in this version of the paper. In the interest of time, I will only briefly talk about 3, one tension on each scale. So tension 1 lies on the institutional scale and it states funding either science or technology. The establishment of the Office of Cyber Infrastructure in 2005, as discussed in the paper, presents an interesting shift in NSF's funding environment. Although science and technology are inherently related to each other, the primary purpose of the NSF is to fund science and discovery research and not technological or infrastructural development. As you will find more details in the paper, software for cyber infrastructure is underdeveloped. So that's an example. Since software is integral to cyber infrastructure, how to pay for software development from a source dedicated to science is problematic, thus leading to the tension of funding either science or technology on the institutional scale. The second tension I would like to discuss is tension 3, which lies on the individual scale. It states providing either unrewarded service to a cyber infrastructure community or building an individual tenure case. As most of you are aware of, researchers depend on scientific reputations as the primary currency for their careers. Traditionally, scientific reputations, tenure promotions, and hiring decisions are based on scientific productivity demonstrated by discovery contributions and peer-reviewed publications. Due to its infancy, cyber infrastructure development actually depends on scientists' direct involvement in the co-production of cyber infrastructure tools for investigating their own science. However, the time investment to work with technologists, supercomputer centers, and other organizations to co-produce these tools and to co-create the future of cyber infrastructure is infrastructural contribution. Unfortunately, this is regarded as a rewarded service in traditional academia. It is here where a dialectical tension arises. When junior scientists are driven by the immediate need to build their tenure cases, they tend to avoid things that might come to be known and focus on short-run survival. We phrase this tension as providing either unrewarded service to cyber infrastructure community or building an individual tenure case. When this tension intersects with the first tension of building science, funding science or technology, the complexity of cyber infrastructure development is compounded. NSF funds science and not sustainable technologies, and academia is about research and not building technological infrastructure. When cyber infrastructure tools are supposed to be built by academics on NSF money, there's a serious mismatch or conflict of interest. So the last tension I would like to discuss is tension 5 on the ideological scale. It is a tension between building cyber infrastructure either for one's theory/methodology or a competitor's theory/methodology. Scientists can be competitive in nature, partly due to their academic training to beat out their competitors in the race to scientific research. The dynamic also plays out in cyber infrastructure development. As previously explained, cyber infrastructure is built based on collaborations between scientists and technologists. Not only do scientists present a research problem to technologists, they frame the problem and imply the correct approach to address it based on their own theoretical and methodological orientations. In other words, cyber infrastructure development is driven by the scientific problems and the theories and methodologies held by the scientists involved. So the dialectical tension plays out when groups of scientists fight to get their intellectual approaches built into the foundation of cyber infrastructure, leading to what we observed as the tension of building cyber infrastructure either for one's theory/methodology or a competitor's theory/methodology on the ideological scale. Our conclusion follows Tracy 2004 and Gibbs 2009 call to embrace the contradictions in the themes. Dialectical tensions may be the driving force for change in a system that is uncertain and evolving. Therefore, we reinterpreted the tensions identified as necessary for a dynamic stability in cyber infrastructure development across various scales. In other words, we are not arguing to dissolve any of these tensions, but to find creative ways to embrace them. Okay, that's it, and hopefully this short video is an interesting overview and you would like to read the entire paper. In addition to the ICA 2010 version, the final version of this paper, which is approximately 20 to 30% different from the one submitted to ICA, has been accepted for publication in the CSCW journal, Computer Supported Cooperative Work, in an upcoming special issue on cyber infrastructure. So if you are interested in that version, please contact one of us and we will be happy to send you that information. Thank you for your attention.